Alright children, we are back to videos. If you hear any background noise in this video, that's because I'm not at the office and I'm at my mother's house, aka my temporary home. Alright, so 6.2 is right angle trig. I kind of changed it up a little bit. I'm going to start story problems today, Tuesday, I should put in quotations, and continue them on Wednesday as opposed to doing them later. Okay. Alright, here we go. So 6.2, right angle trig. So first we got to do some review. So there's some alternate definitions of your trig functions. So when you're on the unit circle, your sine definition is the y, your cosine definition is the x, etc. Now that we're going to be on triangles or right triangles off of the unit circle, sometimes they have their other definitions. Your trig functions have other definitions. So the first alternate definitions are dealing with your right triangles. Here we go. It says suppose you have a right triangle with theta as one of its acute angles. So you have a right triangle. Theta is one of these acute angles. So these two angles in a right triangle are acute, less than 90 degrees, and then there's your 90 degrees. Okay. Then sine of theta is the length of the opposite side, or side opposite of theta, over the length of the hypotenuse side. So sine is opposite of hypotenuse. Okay. So a couple things we got to remember. Your hypotenuse is always across from your right angle. Okay. And wherever your angle is, so in this case I made this lower left hand corner my theta. That means across from theta is the opposite side, and touching the theta is the adjacent side. So whatever's touching that angle you're working with, that's the adjacent. Adjacent means next to. Okay. So you need to look at the angle you're working with and then label your sides accordingly. Okay. It is always sine of theta or cosine of theta. Even when you're on the unit circle, it's sine of something. You're plugging in something. And I told you before, you're always plugging in an angle. Sometimes we know the angles, like pi over 4 or 30 degrees. Sometimes we don't know the angle, like these problems. That's fine. You still need to have your little angle symbol, whatever variable you're using, and understand that you plug in an angle if you had it. Okay. Alright, so now for our other trig definitions. So sine of theta is opposite over hypotenuse. Cosine of theta is adjacent side over hypotenuse. Okay, we're still going off this picture. So cosine is adjacent over hypotenuse. So whatever those lengths are. Remember, we're talking about lengths of these sides of the triangle. Alright, tangent of theta, that's sine over cosine. Okay, so that would technically be opposite over hypotenuse over adjacent over hypotenuse. And when you multiply by the flip, you get opposite over adjacent. Okay, so there's your tangent. And then the rest of the guys, we got secant of theta, which is 1 over cosine. So that's 1 over cosine of theta, which is 1 over adjacent over hypotenuse, which is hypotenuse over adjacent. So you just flip your cosine. And cosecant of theta, flip your sine, that's hypotenuse over, what is this called? Opposite. And what is this? What's next? I'm sorry, I'm having brain farts. I didn't have my coffee today. Cotangent of theta equals flip your tangent, adjacent over opposite. So those are your 6 new trig definitions. Okay, 6 new trig definitions. And remember, you're plugging in angles. So yes, ladies and gentlemen, this is your SOHCAHTOA. So that goes for S-O-H. I could never spell this, so it never helped me. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And again, to get the other 3, you just flip them all. Okay, so that's what we'll be working with. But I have a question. Okay. In blue, notice I changed my color on purpose, children. It says, what if theta was the other acute angle? So I started off with theta being the lower left hand corner, Now I made theta the upper right hand corner because it said if you have a right triangle and theta is one of its acute angles, so one of these angles, okay, then these are the definitions. Okay. Here's the deal. You got to figure out what angle you're working with. So right now we're working on the upper right hand corner now. Okay. So then you relabel sides according to angle. Okay. So now if this is theta, the side that's touching the theta is now adjacent. The side that's across from the theta is now opposite. And again, your 90 or your hypotenuse is always across from the 90-degree angle. So if you're working with a different angle, you have to relabel the sides according to the angle. Notice that label is different. Opposite, adjacent, and now it's adjacent, opposite, because you're working with a different angle. The definitions don't change, but your sides now change. Okay, so we're going to have to be careful of that. Alright, so let's do some examples. So remember when I did the pi over 4 and how pi over 4 came from our famous right triangle 1, 1, square root of 2, and we figured out those famous trig definite, or not trig definitions, famous something. I can't even think, children. I can't even think. We figured out those famous GPS coordinates. Okay, so now let's work with them again. Okay, and so I'm going to label this right triangle. So I want you to consider this guy. I'm giving you a right triangle, and the hypotenuse is 2. My one leg is 1, the other leg is square root of 3, and this happens to be a 30, 60, 90 right triangle. This is your famous right triangle. This is where your square root of 3 over 2 coordinates come from and 1/2 coordinates come from. It comes from this guy. Okay, if we were to plot this on the unit circle, we might have to rotate it some, but plot it on the unit circle. So say we have this triangle, okay, and I want you to find sine of 30 degrees. Alright, sine of 30 degrees. I'm going to circle which angle I'm working with. I'm working with 30 degrees, so according to 30 degrees, I have to now label my sides. Okay, this is always your hypotenuse because it's across from the right angle. According to 30 degrees, okay, this is the one we're working with because this is the angle we're plugged in. The side touching the 30 degrees is the square root of 3, so I would label that adjacent. And the side opposite from 30 degrees that's not touching it is the 1. Okay, so there's my label according to 30 degrees. That's what you got to know. What angle are you paying attention to? That's how you label it. Alright, sine of 30 degrees, the definition never changes. It's still opposite over hypotenuse. And according to our labeling, the opposite side for us is 1 over hypotenuse, which is 2. Okay. So it's all about the angle you are working with. Okay. So that would be your answer. Sine of 30 degrees equals 1/2. Alright, what if I asked for tangent of 60 degrees? Now we're working with a different angle. Now we're working with this guy. So what I'm going to do is I'm going to redraw that triangle so I don't have so much confusing stuff. This is not the same exact triangle, but you know my OCD. You already know. Now you don't have to redraw it, but for note's sake and understanding's sake, I want it to be clear because this is what people get confused on. Oh my god, I can't draw triangles to save my life. Same triangle. Here's 30 degrees. Here's 60 degrees. Here's 1. Here's square root of 3. Here's 2. Alright, hypotenuse never changes. Okay, it's always across, so it's still hypotenuse. But now I'm going to label according to 60 degrees. So now I have to relabel my triangle according to the 60 degree. Touching the 60 degree is the one side, so that is my adjacent. And across from the 60 degree is the square root of 3, so that is my opposite. That's my white out. So notice how the labeling has switched because we have switched angles. Okay, so I redrew it, switched it, and now I can find my tangent of 60 degrees. So tangent is, again, sine over cosine. So it is sine of 60 degrees over cosine of 60 degrees, which equals, again, this is the long way, I'm not ever going to write it again, but I'm just showing you. It is, man, my brain is like not having it today. Opposite over hypotenuse over adjacent over hypotenuse, multiply by the flip, and you have opposite over adjacent. And that is, the opposite side is square root of 3, the adjacent side is 1, so that's equal to square root of 3. Okay. Oopsie. So it's all about labeling your triangle according to the angle you are looking at, the angle you are plugging in. Okay. So what about secant of 60 degrees? So we're still on this red guy. So that secant is the flip of cosine. So that's 1 over cosine of 60 degrees. So that's 1 over adjacent over hypotenuse, which then turns into hypotenuse over adjacent. And that equals hypotenuse 2 over adjacent, which is 1 for us. And that equals 2. So there's secant of 60 degrees. Okay, so it's all about labeling your triangle according to your angle. Okay. Alright, let's do another thing to review all this stuff. Okay. Alright. I'm going to give you a little scenario. You're going to write it down. Alright. Example. If alpha is an acute angle in a right triangle such that tangent of alpha equals 12 over 5. Find all other trig values of alpha. Alright, so where should we start? With the freaking picture. Okay. If alpha is an acute angle in a right triangle, so we got a right triangle, and alpha is an acute angle, such that tangent of alpha equals 12 over 5. Find all other trig values. Alright, let's draw a picture. They get a right triangle, and this is alpha is one of the acute angles, so here's my 90-degree angle. So you can pick alpha be the upper top corner, the lower left corner, it doesn't matter. I'll just do lower left. Okay. Alright, it's one of the acute angles. Okay. It says tangent of alpha equals 12 over 5. Now notice we don't have a number for alpha, and that's fine. We don't need a number for alpha. We got some information. It says tangent of alpha is 12 over 5. Okay, so be careful. Here's a warning. Okay. That does not mean sine of alpha equals 12 and cosine of alpha equals 5. That's not how it works. That's bad. That's wrong. Okay, does not mean that. So we got to write down what this means. It does mean means, okay, by definition, so tangent of alpha equals the opposite side over the adjacent side. So that's telling us 12 is our opposite and 5 is our adjacent. That's what it's telling us, not that. Okay? So, it's like, Sam, what's the big deal? What's the difference between saying this statement, opposite is 12, adjacent is 5, and saying sine of alpha is 12 and cosine of alpha is 5? Sine and cosine cannot be bigger than 1. On that unit circle, even though we're not on a unit circle, we're on a right triangle, by definition, the sine, I don't care if you're on a triangle, where you're at, okay? The sine of a number is not bigger than 1. Whether you're on a right triangle, a unit circle, not a unit circle, if by definition, sine, cosine cannot be bigger than 1, smaller than negative 1. So you can't say sine of alpha equals 12. It doesn't matter what you're working with, sine and cosine will never be bigger than 1, never smaller than negative 1. Alright, there's my rant. Let's go back to the correct. So it says opposite is 12 and adjacent is 5. Alright, so let's label this guy. So we have hypotenuse is always across from the right triangle or right angle. And according to alpha, this is my adjacent side on the bottom, and this is my opposite side on the right hand side. So adjacent is 5, so that's 5, that length. They didn't give us like meters or anything, centimeters, inches, and opposite is 12. So now I have them labeled. Okay. So my triangle is labeled. Got my opposite side and my adjacent side. It says find all other trig values of alpha. So they want the cosine, sine, tan, or where do they have tangent, cotangent, cosecant, and secant. So when it says find all trig values, it's all 6. Okay? So now we need sine of alpha. And that equals what? Opposite over hypotenuse. Okay? But we don't have hypotenuse. How are we supposed to find it? Somebody else out. Pythagorean theorem. Sweet. Alright, Pythagorean theorem it is. Okay. Find other side length using Pythagorean theorem since, well, we have a right triangle and 2 sides. Okay, so you gotta know when you can use Pythagorean theorem. We have a right triangle and we have 2 sides. Alright, so we have a squared plus b squared equals c squared. Okay, a is equal to 5, b is equal to 12, or vice versa. The legs don't matter. But the hypotenuse, okay, is always c. So you have 5 squared plus 12 squared equals c squared. We don't know c, that's what we're looking for. 25 plus 144 equals c squared. C squared equals 169. When you square root both sides, ladies and gentlemen, you better not forget that plus or minus. That will hurt you. So c equals plus or minus the square root of 13. And you will say something like, but Sam, you can't have negative length. And as of right now, sitting on this triangle, you can't have negative length, so c equals 13. Okay. However, my lovely children, when we get back on the unit circle in a couple days, since we're going to be in other quadrants, some of those values are negative. So sometimes we will keep things to be negative length, okay, quotations, negative length, on the unit circle in the quadrants. But just the FYI, your hypotenuse is always positive. That'll never change. Okay, so this is c equals 13. Opposite is 12, adjacent is 5. So there's my triangle now labeled. Okay, now we have it finished. So it's actually a famous triangle, 5, 12, 13. That's a famous right triangle. That's a janky little right triangle symbol. Okay. Now we can find the other trig values. It wanted us to find all of them. So we're going to find sine of alpha, cosine of alpha. You already have tangent of alpha, but I'm just going to write it down to show you how the other ones are super easy. And then cosecant of alpha, because that's the opposite of sine, or the flip of sine. Secant of alpha, and cotangent of alpha. Alright, so looking back at the triangle, sine of alpha is opposite over hypotenuse, as your SOHCAHTOA. Opposite of 12, hypotenuse is 13. Cosine is adjacent over hypotenuse. That is 5 over 13. Tangent we already know, but it better be right according to our triangle. That's opposite over adjacent, which is 12 over 5, and that's what they told us in the story problem. And now to find all the other ones, just flip them all upside down, okay? Because this is hypotenuse over opposite, which is 13 over 12. Hypotenuse over adjacent for secant, which is 13 over 5. And the flip of tangent, which is adjacent over opposite, 5 over 12. Alright, so notice, just to reiterate, sine and cosine, no matter what you're working with, on the unit circle, off the unit circle, can never be bigger than 1, never smaller than -1. 12/13 is less than 1, 5/13 is less than 1. But look at the other guys. Tangent can be bigger than 1, cosecant, secant, because you flip them. So those are allowed to be bigger than 1, smaller than -1. Okay? So we're going to need the Pythagorean theorem to find side lengths and our new definitions of our trig functions. Okay? Just some more information that you may or may not need, but you probably will. I'll just say it, I'm not even going to write it. So right triangles have a 90-degree angle, they all add up to 180, Pythagorean theorem, and then your new trig definitions. Okay. Alright. Let's do one more problem before we get into the story problems, and then I'll end this video. Oh, this is the other type. Okay. So notice in this problem and the problem before, we didn't have the number. Maybe the problem, I don't know. We didn't have the angle. Sometimes we do, sometimes we don't. If we have it, we can plug it in. If not, we just leave it as the symbol, okay, as our variable. Greek variables we like for angles. But sometimes we are given the angle. So let's see how that looks like, what that looks like. So here's an example. Find all missing info, i.e. the variables. Okay, and here's a triangle. Ooh, this is why I don't use pen, children. Where's the pencil? So here's a right triangle. 15 is the hypotenuse. 10 degrees is the lower acute angle. Theta is the upper acute angle. And A is one side, and B is the other side. So I need to find all the variables. And don't forget, theta is a variable, children. Okay, that's probably the easiest one to find. The fact that I just gave you. Okay, theta equals, what does theta equal? Yes, 80 degrees. How, Sam? Who said that out loud and didn't explain? Because the angles in our right triangle should add up to 180. So if I label these whatever, theta plus, I'm making it up, alpha plus 90 degrees, that has to equal 180 degrees. Okay, so I labeled this alpha. So theta plus 10 degrees plus 90 degrees equals 180. Theta, solve for theta, equals 100 minus 80 degrees. I'm sure most of you probably did that in your head. 10 plus 80 is 90. These two add up to 90 all the time, every single time. Okay, because it has to be 90 plus 90 gives you 180. That's the easiest one to do. But just a reminder, all your angles in any triangle add up to 180. Your two acute in a right triangle add up to 90. Alright, either way, however you want to look at it, we found one of the pieces of information. Now we got to find the other ones. Okay. Alright. So now we got to find side lengths. Find lengths of A and B. Okay. Can we use Pythagorean theorem? Because that's how you find side lengths of, right triangles. And somebody says, nope, no, because not enough info. Okay. You only have the hypotenuse. You only have C. Okay. All you got is C. You're going to have A squared plus B squared equals 15 squared. It's not going to work. So we got to go somewhere else. Alright. So what are we going to do? We're going to use our trig definitions. Remember, when you say sine of alpha equals opposite over hypotenuse, that means you're plugging in an angle. Okay? So, I need to label some stuff. So I'm going to redraw my triangle. You can use either angle. So if here's 10 degrees, we know this is 80 degrees, 15, we have A and B. Okay. Alright, if I want to use 10 degrees, okay, so sine of 10 degrees equals, sine of 10 is what? So if 10 degrees, if that's the angle I'm paying attention to and I'm not using the 80, we have to label. Okay, so label sides according to angle. I chose to use 10 degrees. Somebody else could choose to use 8 degrees. So if I'm looking at the 10 degrees, your A is your opposite, your B is your hypotenuse. Okay. And C is 15 because it's always across from the right triangle. Alright, so sine of 10 degrees, so opposite, that's A, over hypotenuse. Look at that. You have two numbers. Okay, this is what you need to understand. That's a number, some number, and that's clearly a number. Okay, now you just solve for A. Alright, how do we solve for A, everybody? Multiply both sides by 15. So A equals 15 times sine of 10 degrees. This is the exact value. Exact value of A. Okay. You can either, if you want to approximate, okay, besides going to a calculator, go to unit circle and find sine of 10 degrees. And multiply by 15. That's if I wanted you to approximate. The exact value for A, that's what I want, so we can leave it alone. Okay? I'll let you guys do that on your own. Alright, now I want to do B. So, let's look at B. I'm going to draw a different triangle. Okay. 10 degrees, B, 15, and here's A, which is, we already found is that, okay? But here's the deal. For B, we need to use B in an equation. We need to use 10 degrees. I'm just going to stick with 10. I could use the 80, but I'm stick with the 10. And we need to use 15. Okay? So, if you notice, we need some trig function that when you plug in 10 degrees, you are using the look at my labeling. How janky is that? Which trig function uses the adjacent over the hypotenuse? So we sine of 10 is the adjacent over the hypotenuse. What trig function is that? So which trig function uses adjacent and hypotenuse? And somebody's going to answer, there's two, cosine and secant. It's your choice. You can use whatever you want. Okay, I'm going to go with the normal one. I'm going to go with cosine. So it's cosine of 10 degrees. So how do you figure out what trig function you're supposed to use? What sides are you using? I'm using the adjacent because I have to solve for b. And I'm using the opposite, or I'm sorry, the hypotenuse, because that's the only number we got left. So I'm going to use what trig function, cosine or secant. It doesn't matter which one. Both of them have adjacent involved and hypotenuse involved, and those are the sides you're using according to your 10. So cosine of 10 degrees is b, which is adjacent, over 15. How do you solve for b? Multiply both sides by 15. So your exact value for b is 15 times cosine of 10 degrees. Again, how do you find cosine of 10 degrees? Unit circle. Okay, but these are exact values. So we found our theta, we found our b, and we found our a. So sometimes the side lengths cannot be used with the Pythagorean theorem because you don't have enough side length information to do that. Instead, you use one of the angles and your trig definitions, SOHCAHTOA, whatever you want to call it. Okay. Now, if somebody used the 80 degrees, their work would look a little bit different. Okay, so let me do that real quick, and I'm ending the video. So what if somebody said, Sam, I don't want to use the 10 degrees, I want to use the 80 degrees. And there's always that one person that want to use the angle that's not given. They always want to be difficult and go find the angle instead of just using what's given. Okay, find whatever you want, whatever your little heart desires. If we use 80 degrees, 15 is still my hypotenuse. This is still a, this is still b. Okay, so we need to find one of the both sides, a and b. So if I wanted to solve for a, I have to use a. I have to use 80 because that's the angle I chose, and 15 is the only other number. So those are the three I'm going to use, and let's label this according to 80 degrees. This is my adjacent so adjacent to 80 degrees. This is opposite to 80 degrees. Our other labelings were different. Okay, we used it 10 degrees. Alright, so according to our 80 degrees is equal to, we're using the adjacent side over the hypotenuse. So which trig function uses adjacent and hypotenuse? And you again would say cosine or secant. So we're going to use the cosine function. That's how you pick your function. What sides am I using? And then that's where I'm plugging into my degree. So I got cosine of 80 degrees equals a over 15. A equals 15 cosine of 80 degrees. So that's what a would be if we use the 80 degree. Look at what a was when we used the 10 degree. Okay, two different guys here. If you plug them both in the calculator, you'll get the same thing. Okay, you should get about 6 inches, 6 feet, whatever these measurements were. Okay, again, you can find that on the unit circle. And you could do the same thing with your b. Okay, if you wanted to use b, you would use b, 15, and 80. So for b, what would that be? It would be plugging in 80 degrees. You would be using the opposite side over the hypotenuse. So which trig function is that? That is sine. Okay, that's how you figure it out. So sine of 80 degrees equals b over 15. So b equals 15 times sine of 80 degrees. It doesn't matter which angle you use. Okay, doesn't matter. So that's the most confusing part, is labeling your triangle according to the angle you are paying attention to. That's why I always do them separate. Alright, this is done.